Good morning. I am Suhasini Goilkar, Finolex Academy of Management and Technology, Ratnagiri. I am giving the presentation on amplitude modulation. Now, first see the basic communication system. In the basic communication system, the 5 blocks are there. The first block is the information source, then transmitter, communication channel or medium, then receiver, and the last one is the destination. In the communication channel, in the medium, the noise source is there. Now, first see the baseband signal means what? Baseband signals means the original signal without any modulation technique. The example of this baseband signal is telephone system for local calls. Now, why these baseband signals are not directly transmitted from source to destination? What is the basic limitation? The basic limitation of by using this baseband signal is why signal cannot travel longer distance. These signals are not possible to reach at the destination with 100% accurate. Noise will be there and it is not possible to get the source same as it is our information same as it is at the destination. That's why the modulation is required. Now first see the modulation means what. This is the basic block diagram of modulation. In the modulation, we require the information signal along with the carrier signal, and after using the modulation we will get the modulated signal, and this modulated signal is transmitted from transmitter to receiver. Now see the modulation. Information signal and carrier signal. Here the high carrier signal is the high frequency signal and information signal is the low frequency signal. This high frequency signal means that is the carrier signal, it amplified by information signal. It amplified the information signal and this carrier signal gives the modulated signal. Means by using this modulation process, modulated signal is transmitted, means the carrier signal, it carries the information and that carrier signal is transmitted from source to destination. No information is there in the carrier signal, only it carries the information. At the destination, again in the modulation we will get the information signal same as it is. Means here this carrier signal is protected the information signal and it carries from source to destination. This is the basic idea of modulation. And now see amplitude, the first basic modulation technique, that is the amplitude modulation. Why this? Before that, see why this modulation is required, means need of modulation. It reduces the height of antenna, it avoids the mixing of signals, it increases the range of communication, it allows the multiplexing of signals, and the main thing, it improves the quality of reception. These are the need of modulation, and because of that, instead of sending the baseband signal same as it is, the modulated signal is transmitted from source to destination. Now see the basic block, first type, that is the amplitude modulation. Amplitude modulation is the very basic modulation technique. See, this is the block diagram of amplitude modulation. First take here the input, means our carrier's information signal. It is in the form of analog signal, sinusoidal signal. And then take the carrier signal. By using the oscillator, generate the carrier signal and take as an input. And remember here, it is also carrier signal is also sinusoidal signal and information signal is also sinusoidal signal. Only here, the frequency of the carrier signal must keep higher than the frequency of our input signal. Suppose consider here the audio signal is our input signal. As we know, the frequency of the audio signal, it is in between 20 Hz to 20 kHz. So, our frequency of our input signal is in between 20 Hz to 20 kHz. Now, take here the carrier signal greater than 20 kHz. means take here the carrier signal in megahertz. Means our carrier signal frequency is in megahertz and our information signal frequency is in kilohertz. Now use the amplitude modulator block. Here it gives just the multiplication of these two signals and we will get here the amplitude modulated signal. Now this amplitude modulated signal is used here in the transmitter, and by using the communication channel it is transmitted from transmitter to receiver. Means here this amplitude modulator block is in the transmitter section. Okay, now see the frequency spectrum of this amplitude modulation. This is the frequency spectrum of AM modulated signal. Here it's amplitude versus frequency. This is the carrier frequency and these are the lower frequencies and higher frequencies, means lower sideband and upper sideband. In amplitude modulation the two sidebands are there, that is the lower sideband and upper sideband. Here the amplitude is MVC by 2, MVC by 2. Both are the same. The frequencies are different, and here in the middle carrier frequency the amplitude is VC. Now find the bandwidth by using why this spectrum is required in amplitude modulation. By using this frequency spectrum, here it is possible, easily possible to analyze the amplitude modulated signal and find the bandwidth of this signal. As we know the bandwidth, what is the formula of bandwidth? Bandwidth means it is the difference between the higher frequency and lower frequency. Here the higher frequency is USB, FUSB, and the lower frequency is FLSB. Now here take the difference between these two, you will get here the bandwidth of the AM modulated signal, and the bandwidth of the AM modulated signal is 2 FB. Here it is possible to find easily the bandwidth of this modulated signal. Thank you.